Everyone mute your system. Everyone mute your system. Okay. So today let us continue the further part of separation of substances. Okay. So this is your what? Lesson name. Is it visible properly?
Yes, ma'am.
Yes, ma'am. Is it visible?
Yes, ma'am.
Okay. So in yesterday's session, what we have studied? What
Separation of group.
Yes. So we have seen introduction part of separation of substances, right? And here again in this we have seen what is mean by pure substances, right? Pure substance. So what is this pure substance? Can anyone answer me?
The material is made by only one substance is known as pure substance.
Yes, very good. So the substance, yes, the substance or the material which is made by only the same kind of particles, right? These are called as what? Pure substance. Okay. So next, here we are going to study in today's session about mixture. So what we are going to study?
Mixture.
About mixture. Is it visible?
Yes, ma'am.
What I have written on the board? What is this?
Mixture.
A mixture.
We can't see properly.
Okay, 1 second.
We can't see properly. And we see substance only.
So everyone mute your system and just concentrate on the topic. So today let us start with the concept that is mixture. So what does this mean by mixture? So forget about mixture. I'll tell you some example. Land, air, then water. These all right? So the land which I am sitting, the land which I am standing on that, or the air which I am breathing, or the water which I am drinking, are they pure? Are they pure? No, they are not pure substances, right? Here land, when we take land, suppose I am standing on the land now, and that land is not a pure substance because that land is consisting of many substances, right? For example, cement, water, soil, sand, okay? The floor or the land on which I am standing, that is completely the mixture of cement, water or soil or the sand. So one more example we will take air. Okay, air. Air which you breathe. Is that air is a pure substance? No. This air is consisting of many gases like carbon dioxide. Yes, carbon dioxide, nitrogen, hydrogen,
Oxygen.
oxygen. Yes. Yes. So air is the mixture of carbon dioxide, nitrogen, hydrogen, oxygen and many more gases. So from this what you understand? That air is a mixture and air is not a pure substance. Even the land or the floor on which you are sitting or standing, that is also not a pure. It is also a mixture. Then again water. Okay, I'll give you one glass of water to drink. You can say this water as a pure substance. Pure substance. Is it true?
No, ma'am.
No. This pure water, even if it is pure water, we can say that this pure water is also having some substances in terms of what? Salts. What it is? Salt. Yes? So what it means? So what I am trying to tell is these are what mixture. Air is a mixture, water is a mixture, land is a mixture because this air is not made by only one gas, but the air is composed of many gases. So I'll write now what is meant by mixture, right? So mixture is any substance which is obtained
From
after mixing one or more than one component. So what is meant by mixture? Mixture is any substance which is obtained after mixing one or more than one components. So this is called as mixture, right? Understanding what I am telling?
Yes, ma'am.
Yes. One more example I'll take. River, right? Have you all seen river? River,
Yes, ma'am.
the fresh flowing water, have you seen? Yes. So this river water is also not a pure water because this river water is also consist of many salts. Many types of salts are dissolved in water. That is why we call river water is a mixture of many substances. Understood? Again, we will discuss some more examples based on this mixture, right? So, how many of you drink milk every day early in the morning? Yes, everyone drink water, milk early in the morning. Why? Because it gives us energy. Yes, here I'll take milk. What it is? Milk. Yes. Is this milk is pure substance or is it a mixture? Mixture. Yes, very good. It is a mixture of water plus cream, or in place of cream we can write milk powder. Right? So it is the mixture of water plus cream, right? So milk is termed as the mixture. Then one more example I'll take, that is soil. So soil is a pure substance or is it mixture? Yes. It is a mixture of what?
Sand,
Water, sand,
rocks,
organic matter. Yes. Broken rocks.
rocks,
So soil is also a mixture of water, sand, organic matter, broken rocks and etc. So which are the examples for mixture? Milk and soil. Now at least you understood what is meant by mixture. Mixture is nothing but it is a component of two or more substances. It is a mixture of two or more substances. So when we take two or more substance and when you try to mix it, you will get a mixture. For example, milk and soil. Understood?
yes, ma'am.
Okay. So here I have taken the mixture of what? Soil. So soil is called as what? Mixture. And the material or the substance which is there inside that soil, that is called as what? Components. What it is called? Components. So which are the components of soil? Which are the components of soil? Water, sand, organic matter, broken rocks and etc. These are called as what? Components of soil mixture. Understood?
Yes, ma'am.
Okay. The material or the substance which is there inside the mixture, that substances we call it as a components. Understood?
Yes, ma'am.
Okay.
Yes, ma'am.
Now, here one more example I'll give you. Yes, Anagha Joshi, can you tell me what is meant by mixture?
Ma'am. Yes, ma'am.
What is meant by mixture? Anagha?
Anything that one or more than one substance is called mixture.
Let Anagha answer the question first.
The mixture
It is a substance.
it is a substance
Yes.
which
It is obtained after mixing two or more components. That is called mixture. One more example I'll take. That is Sharbat. Have you ever drunk this sharbat? Sharbat. Yes. Sharbat is mixture or no?
mixture.
Yes. So what are the components we add in sharbat? What are the components?
Water.
Yes. Sugar, water, yes. So sugar is the mixture of sharbat is the mixture of sugar, water, salt and lemon. So here sharbat is also called as a mixture and this mixture is having these all components. I hope you all understood what is meant by mixture.
Yes, ma'am.
Very good. Now we will go for the next concept, that is properties of mixture. Properties properties of mixture. Yes. So what are the properties of mixture? First one here. First listen to me and explain, then you can answer me, okay? So first property is ratio of component. So what it means? Here generally the composition of mixture is not fixed. For example, here you can take air, right? Air is a mixture. Here in air, the ratio of all gases present inside it is not a fixed, right? Any kind of ratio of that gases may be present inside that air. So first property is the composition of mixture is not fixed and the components of mixture that is present may be in any ratio. Next one, components of mixture retain their own properties. So the components which are present inside that mixture, they retain their own properties. These are what? Two properties of mixture. Next one, here, third one I'll write this side. Okay, so third property is components of that mixture can be easily separated by some of methods. Okay, so the components which are present inside this mixture can be separated, and for that separation we have some methods. One of them is like evaporation. Okay, by evaporation we can separate salt from water. Okay, suppose we have a glass of water and inside that salt is completely mixed with that water. If we want to separate that salt from the water, we can use which method? That is evaporation method. So in order to separate these components of any mixture, we are going to use some of the methods. Among them, one of that evaporation method, right? So this is what? Third property of mixture. Next, what is the fourth property of mixture?
And mixture do not have fixed.
Yes, they do not have fixed melting point and boiling point. So these are four properties of mixture. Everyone should remember these properties of mixture. It may come for 4 marks in your exam. Understood about properties of mixture, or shall I explain it once again?
Ma'am, explain first one once again.
Okay. Just mute your phones. Mute your phones. I'll explain. Here, first property says that composition. Okay. The components which are present in mixture, they are not fixed in ratio. In any ratio, we can add the components to form a mixture. For example, here you can take what? Milk. Okay. So, milk is having a ratio of what? Cream and water. It is not fixed. Right? The ratios of component, it is not fixed. How much you want, you can take the components and mix them together to form a mixture. And next one, second property is they have their own properties. The components which is present inside that mixture, they have their own properties. Third one is components of mixture. They can be easily separated with the help of some of separating methods. And one of them I have explained before this. Okay. And again fourth property is the mixture. These mixture, they do not have their fixed melting point and boiling point. Just for time being, you remember this melting point and boiling point. You are going to study about melting point and boiling point in your higher section. Understood? Okay, very good. Now we will go for next concept of this mixture. If anybody is having doubt, you can ask me later. Okay? Now we will go for types of mixture. Types of what?
Mixture.
Yes.
Mixture.
So which are those types of mixture? First one, homogeneous mixture. So what is the first type of mixture?
Homogeneous.
Homogeneous mixture. Second one, heterogeneous mixture.
Heterogeneous mixture.
You all are feeling sleepy or what? Sit straight. Anagha, Nandakumar, switch on your cameras. Fast. Yes. Sakshi Patil, Tilak, Swaraj, switch on your cameras. Nandakumar, hurry up. Okay, so now we will go for types of mixture. So what are the types of mixture? There are two types of mixture. First one is homogeneous mixture and heterogeneous mixture. Now what is meant by homogeneous mixture? I'll explain you with the help of example. Right? Okay. Now again I'll take a glass of milk. What I'm taking?
Glass of milk.
Glass of milk. Right? So milk is a mixture. And here in milk, are you able to see which components are mixed inside it by your naked eyes? Directly by your eyes, can you see which components are present inside the milk? No, we cannot see the particles which are present inside this milk. We cannot see. For example, here milk is the mixture of water and cream, right? And this cream and this water separately we cannot find it out in the milk. Why? Because it is completely mixed, right? So milk is completely mixed. That is why we cannot see the particles of cream or the particles of water separately. So the mixture which are completely mixed, which are completely dissolved and we cannot see by our naked eyes. Such mixtures are called as homogeneous mixtures. Understood what is meant by homogeneous mixture? Homogeneous mixtures are those where we cannot see the particles present inside that mixture. They are completely evenly distributed in that mixture. It is completely evenly distributed all over that mixture. So that is why we cannot see which particles are present inside that mixture. So such kind of mixtures we call it as a homogeneous mixture. One more example, that is air, right? So air is also a mixture. So air is mixture of what? It is a mixture of carbon dioxide, nitrogen, hydrogen, oxygen. Yes, can you see? Yes, can you see these all carbon dioxide, nitrogen, hydrogen? Can you identify these gases in the air? No, you cannot identify these gases because these all gases are completely mixed among themselves. We cannot identify which all gases are there inside the air. So air is also an example for what? Which mixture? Which mixture?
Homogeneous.
Yes, homogeneous mixture. One more example, that is, we'll take some more examples of metals. I'll take example of some metals. Okay, gold, gold, copper. These are all metals. Okay, or alloys. So, in these metals or alloys, can you identify how much the particles or how many particles are present inside them? Can you identify? No, you cannot identify because here also the components of copper are completely distributed and evenly distributed throughout that mixture. So these are also an example for homogeneous mixture. Understood?
Yes, ma'am.
Okay. One more example, that is sea, ocean. Have you seen ocean?
Yes, ma'am.
Sea water.
Yes, ma'am.
Okay, in sea water, again there are many components like salts, ions, next water, soil, sand. So sea water is mixture of these all components, that is salt, ions, water, soil, sand and rocks. But we can see this. Are you able to see the salt and ions which is there inside the sea water? No, we cannot see salts and ions which is there inside the sea water because it is also completely dissolved. Dissolved means completely mixing. Salts and ions are completely mixed with what? The water which is there inside the sea. So this is also the example for what? Homogeneous mixture. Understood? So, homogeneous mixtures are those in which all components are evenly distributed. Evenly distributed in a sense they are completely dissolved, which we cannot see by our naked eyes. Okay. Now, we will go for next type of mixture, that is, so which is the second type? Heterogeneous mixture. Okay, for heterogeneous mixture, I'll give you an example. I'll take again a glass, and in that glass, I'll pour water, and I'll take a teaspoon of sand. What I'm taking? Sand. Okay. So this sand I will mix with the water. So this is what? Water, and with this water I am going to mix sand. Now I will stir this completely. I will mix that sand with the water completely. Right? And I will make this glass to leave for 5 to 10 minutes. Now what do you observe in this? Will that sand completely mix or completely dissolve in water?
Yes, ma'am. No, ma'am.
No, the sand will not dissolve. It instead what will happen? It will settle at the bottom of water glass. Here sand will come and sit at the bottom of that water glass, and water will settle at the top of that glass. So this is what? Sand, and this is water. So here we can see that sand particle inside that water, right? The sand particles which we have mixed with the water, and we will allow that water glass to leave for 5 to 10 minutes. After 5 to 10 minutes, what will happen? That sand will settle down at the bottom of water, leaving water at the top. And here in this case, we can easily saw the sand particle. So this mixture we call it as a heterogeneous mixture. So what is heterogeneous mixture? Here in heterogeneous mixture, components. Which components here? Sand and water, right? These components are not distributed evenly, and they are not dissolved completely. So this is what everything about heterogeneous mixture. So heterogeneous mixtures are those where in that heterogeneous mixture components are not evenly distributed, and even they are not completely dissolved. Such mixtures are called as heterogeneous mixture. Understood? Yes, ma'am. Can you give me some more examples for heterogeneous mixture? Can you give me some more examples for heterogeneous mixture? What is this? Granite. So granite is also an example for what? Heterogeneous mixture. This rock or this stone, or it is used for putting tiles in your home. Have you seen that? Yes, that is also not a homogeneous, but it is a heterogeneous mixture. We can see the components which are present inside that granite. Understood? Yes, ma'am. Okay. Okay. Now I'll ask you one question. This is what? Water. Okay. This is what? Water. Yes. Now, in this water, I will add chalk powder. What I will add? Chalk powder, and I will mix it completely. Yes, I will mix it completely. Then which solution or which mixture you will get? Homogeneous or heterogeneous? Which one you will get? Homogeneous. Only one answer I got. Is it homogeneous or heterogeneous when I mix water and chalk powder? Yes. The mixture of water and chalk powder is heterogeneous mixture, right? So when you mix chalk powder with the water, it will not mix. Instead, it will settle down at the bottom of water. You can see the chalk particles inside that water. You can see it, right? So this water and chalk powder mixture is example for heterogeneous mixture. Understood? Yes. So till now, what all things we have studied, I'll just show you by chart. Remember that. Okay. So first one we have seen about matter. Okay, in previous lesson we have seen matter. Again, under matter we have two types. What are those? First
But
is
pure substance, it's the element compound.
yes.
Pure
First one under
mixture.
matter we have pure substance. Pure substance are those which are made up of only same kind or one kind of particles or elements. Hmm? Next one, again under matter we have mixture. So what is this mixture? Mixture is the substance which is made up of two or more components. It is a mixture of two or more components. Next, again pure substance we have what? Element. We have what? Element. Yes, compound. So pure substance is made either of elements or compound. So that is why this is called pure substance. Next one, again under mixture we have what? Yes, homogeneous mixture and heterogeneous mixture, right? So this is what the chart for matter till whatever we have studied. So in short, I will explain this chart. Just remember nuclear system, okay? So matter we have, again under matter we have two types. One is pure substance, one more is mixture. Pure substances are those substances which are made up of either elements or the compounds. And mixture, again in mixture we have two types, that is homogeneous and heterogeneous. So homogeneous are those substances which are the mixture in which particles are evenly distributed and completely dissolved, which we cannot see by our naked eyes. But in heterogeneous, these are the mixtures where here we can see the particles inside that mixture by our naked eyes. They are not evenly distributed here. They are not evenly distributed. They are not completely dissolved. Understood? So remember this flow chart. You will better keep in your mind if you remember this chart. Anybody is having doubt in this session? No? No, ma'am. Okay. You can leave the meeting.